Hello, I'm Nick Maxwell, and for many years, I taught philosophy of science at University College London, and I've been arguing for many years that we need to change science and change universities more generally, so that the whole enterprise much more actively and rationally and effectively helps us to solve our global problems, our big problems of living, which is not really what universities do today. They're devoted much more, and certainly in the first instance, to the pursuit of specialized knowledge. And what I want to talk about now is the apparently outrageous claim that the scientific community doesn't understand the nature of science. Most scientists accept, without question, the idea that the essential thing about science is that claims to knowledge, theories, potential laws are assessed, decided upon whether they should be accepted or rejected on the basis of evidence, on the basis of experiment and observation. And the crucial thing is that in science, nothing must be accepted about the nature of the world independently of evidence. Well, this view, which one might call standard empiricism, doesn't actually work. Because if you look at theoretical physics, the fundamental part of the natural sciences, you find that physicists only ever accept a theory that is unified. You can't have a theory that is a sort of patchwork quilt theory that says one set of laws over here for that range of phenomena, another set of laws over here for another range of phenomena, and so on. The same laws have to operate throughout the range of phenomena to which the theory applies. But you can always concoct endlessly many theories which are designed to fit the facts even better and make more successful predictions than the unified theories that we accept. Newtonian theory, Maxwell's theory of electromagnetism, quantum theory, Einstein's theory of general relativity, or the current quantum theory of fundamental particles and the forces between them, which physicists call the Standard Model. So the fact that all these empirically more successful but disunified rivals never get considered for a moment means that there is a big assumption built into the whole enterprise that all these other disunified theories, however empirically successful they may be, are false, and so we can ignore them. In other words, that the universe has some kind of underlying unity, that there is a unified pattern of physical law running through all phenomena, that the universe, in other words, is physically comprehensible. There is a true theory of everything that is unified, yet to be discovered. Well, this is a highly problematic assumption. How do we know it's true? It's a kind of article of faith. It's exactly for this reason that physicists, scientists, the scientific community in general, pretends that this assumption isn't being made by science and everything is just assessed solely on the basis of evidence. But that isn't actually what goes on in science. And it's really important that this big, influential and highly problematic assumption is made explicit in science so that it can be improved and developed as science proceeds. And we do find that something like that actually goes on in science, but he goes on in a kind of surreptitious, underhand way without being explicitly acknowledged. So it really is the case that the scientific community doesn't really understand the nature of science. What scientists actually do doesn't quite accord with what they say they're doing. There was one very famous physicist who was aware of this situation, Albert Einstein. He said, if you want to know anything about the methods that physics employ, don't attend to their words, look at their deeds. Einstein was well aware that what actually goes on in science is not what scientists say goes on. And there's another really important reason why we need to get clear what the real methods of science are, because these methods can be generalized and applied to other problems that we face, even more urgent problems than scientific problems, such as the climate crisis and population growth and the destruction of the natural world, and problems of war and poverty. We can learn from scientific progress, but from scientific method, from the progress-achieving methods of science, but we really need to appreciate what really goes on in science, and not just what scientists say goes on, especially because if in science the aims are problematic, this is even more the case in life and in politics, where above all we need to learn how to improve problematic aims as we live, as we try to grapple with these issues. So my hope is that the scientific community will, before too long, come to a better understanding of the nature of science.